This is our Voyager spacecraft. We had Voyager 1 and Voyager 2 launched in 1977. Voyager 2 was actually launched first, and then Voyager 1 launched a couple months later, just on a faster trajectory. And the size that you see right here is the actual size that's in space right now. This is the size, and again, it was put in a cone of a Titan rocket and then deployed out there.
What year?
I'm sorry?
What year?
1977. And pretty much, Voyager's pretty much hold a lot of records. Voyager 2 pretty much went by all 4 gas planets: Jupiter, Saturn, Uranus, and Neptune. And Voyager 1 just went through Jupiter and Saturn, kind of did a little detour and is now heading out towards the edge of our solar system. So these right here are our antennas. These are the high gain antenna, and above it, the low one, the little gold foil thing, is the low gain antenna. That's what we use to speak to the craft right now. Voyager is about 7.9 billion miles away. That's how far it is. So when we send transmissions from Earth, it starts, we send a transmission using radio waves. Radio waves are traveling at the speed of light. Does anyone know what the speed of light is?
186,000 miles per second.
Exactly. 186,000 miles per second. That's how fast light travels. So when we, just to give you an idea how fast that is, like if I had a flashlight and I turn on that flashlight, assuming it was strong enough to go around, I can turn on a flashlight, and in 1 second that beam of light will travel around the planet 7 times. In 1 second, that's how fast light travels. And if I can aim it at the moon, it'd take like a second and a half. The sun were to go out right now, we'd still have sunlight for another 8 more minutes before we know. Yet the closest star that we have in the sky, if I were to aim a flashlight at it, would take over 4 years at 186,000 miles per second. Yet when we want to speak to this right here, speak to Voyager, it takes 11.5 hours using radio waves, traveling at the speed of light. Sort of as a space infrared telescope facility, we can use infrared to detect like a lot of heat that's in outer space right now. There's like a lot of dark cloud and dark dust and material that we cannot see through a lot of land-based telescopes. Infrared will be able to see through that, and everything in the world gives off heat. So like if you took like this radio threw it in space, it would be giving off heat in space. So we can actually detect all types of heat through infrared. And infrared on ground base, like a lot of like the police will use infrared on their helicopters. When it's like pitch black and it's night, and they know there's a bad guy like hiding underneath the bush, but they can't see him. They'll use infrared goggles, and I'll see this like glowing heat source, and that's like infrared. This is our clean room. In this room right here, this is where we build all the spacecraft in a very clean environment. And this is a class 100,000 clean room, meaning that for every cubic foot of air, there is 100,000 particles of dust for every cubic foot. If you look straight ahead, in the center of that room, that gold box is the actual Mars rover that's going to be going to Mars. You can see like the arms that's stretching out, the wheels are going to be attached to that gold box, and that's going to be the actual size. Ladies and gentlemen, this is the end of the tour, and I thank you.